Okay, so we'll just randomly pick a few questions from this page to do, and then I'll let you guys give you guys time to try questions on your own. So number 17 is similar to the ones that we did in class before, but obviously with these word problems, you change it a little. It's a whole new question. So the hypotenuse of a right angle triangle has length 17 centimeters. Okay, the sum of the length of the legs is 23. So if I say this is, well, with these ones, so this plus this has to equal 23. Well, remember we want to throw in a variable somewhere, right? Because we need that x squared, and so forth. So I'm going to call this x. If this is x, then this is 23 minus x. Right? So that when you add it up, when you add up the two sides, you'll get the 23. Does that make sense? So if I call this length x, then this length would be 23 minus x. Right? Because when I add up the two sides, the sum of the length is 23. So what are their lengths? Now to connect this idea, we do the c squared equals a squared plus b squared. So 17 squared equals x squared plus 23 minus x squared. Okay. So 17 squared is 17 times 17, 289 equals x squared. And then you're doing FOIL here. And first, outside, inside, last. Say that again.
So, like, shouldn't 23 minus x squared in brackets be 23 minus x bracketed 23 plus x?
Oh, no. So this is 23 minus x squared is the whole bracket written itself. You're thinking difference of square, where one is minus, one is plus. Yeah. Okay. So 289 equals x squared plus 23 times 23, 529. Okay. Minus 23x minus 23x minus x squared. Did I do something wrong? I think I did something wrong here. Because my x squared is gone. The sum. Huh? What? Real quick. Alright, wait a minute. Let me pause this first. I think I just. Okay, I found my mistake. It's plus x squared. Right. Why I realized that I made a mistake is I saw that x squared minus x squared, that canceled out. And so if it canceled out, I can't get my quadratic equation. It's going to become a line. Right? So yes, thank you. Negative x times negative x is positive x squared. So now it makes sense. Okay, so 289 equal 2x squared minus 46x plus 529. Move this 289 over. So 2x squared minus 46x, 529 minus 289, I get 240. Okay. Now I am trying to solve for x. So what should I do? Am I doing completing the square or am I doing quadratic? What am I doing? Quadratic, because I'm solving for x. Okay. I could do either quadratic or do factoring. Let me see if factoring works. I'm thinking factoring will probably work as well, but I don't want to waste time, so I'm just gonna do the quadratic. So that's how I decide if I should do the quadratic or if I should do factoring. If I see the factors right away, definitely do factor because it is faster. But if I don't see it right away, I'm not going to waste time. I'm just going to go straight to the quadratic formula. So negative b plus or minus root b squared minus 4ac all over 2a. So 46 plus or minus square root 46 times 46 minus 2 times 4 times 240, 196 all over 4. Square root 196, I get 14. So 46 plus or minus 14 over 4. Do my 2 arrows. So one answer is going to be 46 plus 14 over 4. The other is going to be 46 minus 14 over 4. Okay. So x equals 46 plus 14 gives you 60. 60 divided by 4 is 15. On the other hand, 46 minus 14 gives you 32. 32 divided by 4 gives you 8. Okay. I have 2 answers right here. Am I taking both answers or am I taking am I rejecting any answers? What do you think? Should I reject any of these? Okay. That's when you have to go back to your original question and look at the diagram right here. Okay. So when x is 15, okay, that means my diagram looks something like this. So this is 15 centimeters. This was 17. This is 23 minus 15, which is 8. Okay. This diagram right here, okay, this was, if x is 8, which is, I'm basing it off my diagram from here. So if x is on the base of my triangle, this is 17. And then this right here, 23 minus 8 is, 23 minus 8, 15. Yeah. So therefore, what was the question asking? What are their lengths? So their lengths is actually just the same triangle, but one drawn the sideways like this and the other drawn like this. It's the same triangle. Like when you rotate it, it's still the same length. So in this case, you would actually take, well, it's, when you sub it in, you get 8 and 15 as the 2 side lengths. When you sub in 8, you get 8 and 15 as the 2 side lengths. So in this case, you're just saying, therefore, the side lengths are 8 centimeters and 15 centimeters. Okay. But the key right here is to solve for x, you're doing quadratic formula. Okay. So let's try to find one where we have to do completing the square. Let's do 16 then. 16. What is the maximum height of the volleyball? All right, so the word maximum tells us we have to do completing the square. We're doing finding the vertex. Okay, and when does it occur? Which means that it's still asking you about the vertex. Okay. Okay, so let's do that. Number 16. 16. H equals negative 4.9t squared plus 14t plus 2.5. Okay, so let's see if we still remember how to do completing the square. You need to know it for tomorrow. What's my first step? Rosie? Out of the first two terms. So even though I have a nice number 14 right here, yep, I do have to factor that out. So 14 divided by negative 4.9 gives you negative 2.857. Okay, it looks really weird, but that's part of the steps. That's what you have to do. Okay, I divided 14 by negative 4.9. Okay, next I'm gonna take half of this number. So half of this number, negative 2.857, I'm gonna divide it by 2 and then square it. Okay, dividing it by 2, I get negative 1.43. And then when I square it, I get 2.04. Okay, so I'm gonna plus 2.04 and I'm gonna minus 2.04. Okay, H equals, now I'm gonna factor out that fourth term. When I factor it out, remember I have to multiply it with this negative 4.9. So that plus that. I'm going to bring this out. So this times negative 4.9, I actually get a nice whole number. I get a 10. This times this gives you 10. Okay, so negative 4.9. Now I factor this. This factors down to what? Yeah, Tasia? Yeah, so we just, this number right here, t minus 1.43. Okay. And then here, it just adds to 12.5. Okay, so my vertex, 1.43 and 12.5. In the context of the question, what does this vertex represent? It's a volleyball match. Jenny serves the volleyball. Where h is the height in meters and t is time in seconds. Okay, so what did we just solve for right here? Rosie? The vertex, okay, but in terms of the context of the question, if I want to write a therefore statement, Eiko? Is which one is it? 12.5, good. And what is this 1.43 then? Time in seconds. Okay, so in 1.43 seconds, the volleyball, reached a maximum height of 12.5 meters. Okay, so it's great that you guys know how to do completing the square and finding your vertex, but you have to be able to sum it up and say, okay, I found a vertex. What does that mean? What was the purpose of completing the square? So it was for you to be able to find a vertex, which that 1.43, the x is represented by time in seconds, and the y was the height in meters. Okay. Part B. If a player on the other team contacts the ball at a height of 0.5 meters above the court, how long does it take for the ball to reach her? Round to the nearest seconds. Okay. So again, this is a little hint. Okay, so looking at this, you might be thinking, what am I trying to do? Am I finding vertex, or am I solving for x? If you are not sure, here's a little hint. Round to the nearest second. So seconds, time. Was that x or y? Taisha? X, right. So therefore, you're solving for x. Okay. So this is like a little hint already. It's telling you round to the nearest second, round to the nearest time, and time was our x. Okay. So to solve for x, that means we're doing here. I'll start it off, but I won't write out everything because it's just a quadratic formula again. So for part B, you're substituting 0.5 in for h. So negative 4.7t squared plus 4tt plus 2.5. Okay. So when you move this, negative 4.9t squared plus 14t. When you move this over, you subtract, so plus 2. Okay. And then from here, you'll do your quadratic formula, and then you will solve for t. Quadratic formula. To solve for t. Alright. Once you solve for it, that will tell you, so your therefore statement would be, therefore, the volleyball reached her after 5 seconds, for example. Okay. Let's see. Is there any other questions in here that I want to take up with you guys? Okay, I'll throw in one more. I'll throw in this one. We did some of these yesterday as well. So, given 6x squared minus bx plus no, actually no. Minus 8x. We'll say 8. That's fine. 8x plus k. Okay. Find k so that this parabola gives 0 x-intercepts. Okay. So, so what is the formula that I should use? Not the full quadratic. I could just do part of it. Mohammed? Yeah. Right. Okay. Good. Alright, so this is part of the quadratic, but if we just want to figure out this part where it gives 0 x-intercepts, we can just use this short way. Okay, so b squared, b, -8 minus 4 times a is 6, c is k. 64 minus 24k. Okay, move that 64 over. I get -64. And then when I divide it, what is my final answer? What's 64 divided by 24? 2.6. 2.67. Okay, what's my sign? Mohammed? Greater than. Good job. Alright, because when you divide by a negative, don't forget you have to change the direction of the sign. Okay, so what's one example of this equation then? Y equals 6x squared minus 8x. An example? Eagle? Yeah, sure. Plus 2.68. Yeah. Anything greater than 2.67, that's a valid answer. So if you were to plot this on a graph, you'll get something like this. Okay, where the parabola is above your parabola is above the x-axis, so you have no x-intercepts. Okay. If how would your graph look like if I said there's just one x-intercept? Yeah. Perfect. Yeah. It means that your vertex is on your x-axis. This is an example of a graph where there's only one x-intercept. And then similarly, if there's two x-intercepts, any problem. Okay. So you have no x-intercepts, one intercepts, two intercepts. Okay. So we went over quadratic, we went over the we went over the quadratic formula, we went over completing the square. I think it's good. Okay, so I'll give you guys the rest of the class time, 45 minutes, to try these questions. You can do all of them if you want, or you can just pick and choose the ones. Okay, so for example, like these ones, which are the more easier ones, maybe just do one of these. And then here, do one of this, do one. If you get the question wrong, do another. And then, but make sure you do try to get to the word problems. Okay, so tons of word problems for you guys to try. We took up some already. And yeah, that's it. If you have any questions, feel free to come on up. I'm right here. If you have questions tomorrow, you can come to me at lunchtime. I'm here, preferably beginning of lunch, so I don't have like people coming in every 5 minutes. Okay, so beginning of lunch if you have any questions. Okay.